Hi, welcome to the Signal Path. Today we're going to try and repair this Agilent E7495B 10 MHz to 2.7 GHz base station test set. Now from the name of it you may think, oh, but base station test set must be a very specific instrument used for very particular applications, but on the contrary, this is a really capable unit that if you can get your hand on would be a great addition to your lab, especially for beginners, because it is a full 10 MHz to 2.7 GHz spectrum analyzer. That's its most basic function, but it also has return loss measurements, two-port measurements. It has a continuous wave generator inside, and this one is actually equipped with an option to do arbitrary waveform generator, modulate all the way from 10 MHz to 2.7 GHz. It has a power meter interface directly connected to it, so if you have a power sensor, you can do power sensor measurement on it. It has quite a few different applications already loaded on it. This one has a lot of the features installed, and it's a very loaded unit actually. It has GPS, it has just a ton of stuff that you can do with this. If you have this, you can do quite a few RF measurements with it in your lab. So it's a nice unit to have, and I picked it up for next to nothing as a broken unit, and it doesn't power on. These things obviously are battery operated. By the way, these are built like tanks. I mean, you cannot destroy these, at least not mechanically, but I believe that something must have happened to the battery, and the power supply management system of it has burnt down, and it accepts a DC voltage from an external power supply, so we'll have to power it with one of the lab power supplies here because it did not come with the adapter. And this battery is most definitely dead, so we're gonna have to get rid of this and see what's going on with it. Now it smells like something's burnt up, so that will be our initial clue to look for damage from that perspective, so we'll definitely do that, and I'll give you a quick look around just so you can see all the different ports that it has and all the different interfaces you can have. But I'm excited to take it apart and see if we can fix it. It should be running Linux when it runs up, so let's see what happens. And as I was saying, you can see it has quite a different few interfaces there. This is our port 1, which is the RF output as well as the standing wave ratio measurement. So using this port, you can actually measure distance to fault in a cable connected to an antenna system, or you can use it in a loop to measure in a two-port configuration. This is our RF input. We have the GPS antenna. There's two events and trigger ports here, which are BNC. Here's a 50 MHz output used for power sensors. Here's a power sensor interface. It has two serial ports dedicated for programming and interfacing with other instruments, and there is a GPIO also configurable from inside the unit, and there is the DC input. You can see that this is quite weatherproof actually, so it can take quite a bit of abuse. It's supposed to be used outside, and then people throw them around and it can fall in mud and it can have rain on it and so on. These are really nicely built. There's also a couple of other interfaces on the side. You can get this around to this side. Here we go. And I was trying to open these, and they are really tough to open. Oh geez, let me see, I'm gonna have to use this. There we go. You can see a couple of other interfaces, or a LAN, a USB, there's a headphone jack, a couple of other TXRX ports over here, compact flash, and PCMCIA. So you can see that it runs, obviously has a full PC in it, which runs Unix or Linux, and if you can power it on, we'll find out. So far so good. So let's go ahead and see what I have to do to take it apart. It's not going to be very easy to open because obviously it's very nicely sealed, but enough screws can be taken off. Eventually it'll open up. Alright, and after some struggling, we're in, and you can see that this thing is completely sealed because it does have this O-ring around it, and it will prevent any moisture from going inside. So they've obviously done a very good job with that. And you can see these longer cables that come out of the main unit are designed to connect directly to the front panel, and the front panel is a completely separate module. Check it out, it looks pretty good. And I'm gonna put this away because most likely the problem is not in this portion of the instrument anyway. So now we have to take a closer look and see what's going on and isolate the power supply section. And here's a top view of it, and this both simultaneously looks very impressive and a little bit messy. There's a lot of modules here. It's clearly built to be installed as the different options are ordered, and this has all the options, so you can see it's crammed full of components. And I recognize some of these things right away. For example, this section over here is likely responsible for the power meter and power sensor section. This is a 50 MHz reference generator for the power meter, and obviously all the other RF sections and components which are responsible for the spectrum analyzer, the arbitrary waveform generator, plus the tracking generator and all the other things. And there's actually still some unpopulated connectors, perhaps for even more options that these things could be retrofitted with. Now unfortunately the power comes from here, so it's right at the very bottom, so it's layers and layers of boards before the power supply section can be reached. And that's a bit of an annoyance, because I don't know how I'm going to reach that without completely disassembling it. It looks like the power supply is at the bottom, and no, I cannot reach it from the other side. The other side is completely closed. This chassis, as far as I can tell, cannot be accessed from the back. I'll take a look and see if there's a way to open it, but I'm not that hopeful. So let's go ahead and see. Let me just think about this a little bit and see if I can find a way to get inside, and we'll come back right to it. Well, I have good news and I have bad news. The good news is that I managed to take the entire RF section, which comes out all together as one block, out of the unit, and this is the unit as it is. And the bad news is that I don't think I can put this back together again. There is just so many things hacked together. I have to say it's not as elegant as I'm used to seeing Agilent and Keysight instruments to be. This is more, look at just how many ribbon cables there are, and it just seems like it's just a bunch of pieces put together and not really well engineered, at least not mechanically. But anyway, the power supply is all the way at the bottom right there, and so we have to take the motherboard out, which has the processor, the RAM and everything in it, and from there we should be able to access this. And I can smell already the burnt smell there, so we should at least be able to visually detect some kind of damage, I hope. And here we are. It looks kind of like a war zone here, but I've taken the main power supply out. You can clearly see some damage over here, and there's a few other components around here which look like the one that's damaged, and they all look like tantalum capacitors. In fact, the smell is very familiar if you've ever blown one of these up accidentally. The question is, why has this happened? Why has it blown up? Is it because somebody reverse biased it, or is it for some other reason? I'm not sure. So I'm going to go ahead and try and remove that, clean it up a little bit so we can find out where the traces were. And this is the main power connector that comes into the unit. And there's interesting a button here which may be something that you can just turn on and off on itself. So I'm going to power this on by itself. There will be no chance of damaging it any further anyway if I just power it on, even if it's not connected to anything. It should be self-contained. So let's go ahead, clean it up, remove it, and then we can always replace it with another capacitor afterwards, and let's see what happens to it. I'm very eager to find out. Alright, I went ahead and I replaced the tantalum capacitor with the one that is similar in specification, and before I replaced it I quickly measured it, and it was presenting itself as a 3 ohm resistor, so it was indeed causing quite a bit of problem, essentially shorting out the power supply as it was coming in. So now that it's replaced, I'm gonna just plug it into power to make sure everything's looking good, and then I'm gonna reverse and try and reassemble it. I'm sorry if I'm rushing through this, is because I want to make sure I remember how to put it all back together. So let's go ahead and quickly see what we can do. And here we are. I've plugged it into the power supply over there. You can see I've connected to my Agilent power supply there, and there you can see it 15 volts is drawing 17 milliamp, which is in standby mode, and there's a little LED that's directly on this little board, and it's lit, so it looks good. I think we've done enough repair on it to be able to take it back and start reassembling it, and along the way I can keep plugging it in to make sure that it is responding correctly. And as we build it up, if I find something interesting, I'll just make a quick comment on it until we're back to a fully assembled unit. Alright, the power supply is back in, I think, and it's interesting to see the mechanical design of this in a way. What they've done is that every time there's a connector, either the connector is clipped in with these brackets, like these ones, or there is a metallic piece on top of it which is screwed down and holding the connector in place, preventing it from ever coming out. Because remember, you're supposed to be able to drop this, and of course you don't want things to pop out, so everything has to be really secure inside, and I think they've done a fairly good job to do that. And by the way, it looks like this back panel actually does come off, but it wouldn't come off unless you reach all the way to the bottom and take everything out, because it's all screwed together, so I'm not even sure what the point of that is. But anyway, that was the only way to get to it, was from the top. So now that I've put this in, this next to put the component is the motherboard. Actually, I can show you. Take a quick look at it over here. And here's the motherboard. Everything is just in pieces, and it's interesting to see. Again, it's a very basic design. This is where the Ethernet and the USB ports are, and there's actually keyboard connectors which do not come outside of the unit. They're only exposed from the inside of the unit. Memory is directly soldered onto the motherboard itself, and there's the transceivers for one of the options that's here. It has nothing to do with the motherboard itself. And yeah, looks pretty straightforward. So now the question is, how does this go in? Where do all these connections go again? And here we have the motherboard back in place, and you can see all the different connections now waiting to be connected to the RF module, which is supposed to sit on top of everything here. And I hope that I've connected everything correctly. And this is the battery portion, by the way. This is where you would slide in 2 batteries. This unit can accept 2 of these because its power consumption is quite high. So in order for it to run for like an hour and a half or so from these 2 batteries, it needs 2 of them. And then these batteries connect to this vertical board, which then is connected through these cables to the same PCB that I just repaired a few moments ago, and that's where we get all of our DC, including the charging circuitry, embedded directly in there. So there's quite a bit of DC-DC conversion that is done at the very bottom, and you can see the way they've layered this. They put the power supply as far away from the RF portions as possible, the motherboard sitting at the top, and the whole RF section is then shielded by its own cage in there. So let's go and try and put that back in there and see if we can get it to boot up. Alright, check it out. I put it back together, or at least I think I put it back together. Sorry for rushing this. I'm just really busy and I didn't have much time to shoot, and I wanted to make sure I get something out to you guys. So anyway, I put it back, as I said, all together now, and I'm connecting it right through here with a plug to my rival power supply. So what I'm going to do is maybe raise the voltage ever so slightly, because it did have a short before and it did have other issues. So let's see what happens here. So let's go ahead and take a look here. I'm gonna enable the power. So right now it's 0 volts, so let's crank it up slowly. There's 1 volt. Doesn't seem to take any current. Oh, 2 milliamps. 2 milliamps is nothing. 7 doesn't have a short anymore. 8, 9. Oh, there we go. There we go. Oh, it's doing something. 11, 12. Oh, 2.7 amp. What? Oh, right. I forgot. I actually put the battery back inside the unit. Just to see what happens. So as you can see, I believe it's, yeah, there you go, the battery light's blinking. There you go, that's pretty good. That's a step forward. Now the battery is probably dead. I don't think it's gonna actually hold charge, but this is a good sign that it is actually trying to charge the battery. It's trying 2.7 amps. It's putting that into the battery. That's 32 watts. Let's go to 15 volts, which is somewhere nominal. There you go, 2.3 amps, 34 watts. I imagine that's dumping that into the battery, and I have only one switch blinking. Let's power this on. Oh, nothing happened. Oh, there we go. I just didn't push it hard enough. There it is, and nothing on the screen. Let's see some lines. What the heck is it doing? Look at that, it looks like it's booting. It's really dark. Oh, brighten up. Not bad, check it out. It looks like it's running Unix. Yeah, it's definitely running some kind of a Unix, Linux up. Yeah, there you go, Linux is definitely running that. And it's mounting file systems. This looks good. Well, let's see what happens. Wow, it's got lots of stuff. Yeah, there you go, starting flash, installing from /flash/Linux, some onboard flash memory. DHCP client, looks good. So now let's wait a little bit and see if it boots up. And check it out, looks like it's fully booted. I haven't connected anything to it yet, but at least you can see the list of quite a few applications that it has built in. It has antenna and cable analyzers, spectrum analyzers, and a bunch of tools under that. The power meter, it has a full backhaul analyzer, transmit analyzer, it has over-the-air analysis. Oh, so many stuff built into it. Test software, oh yeah, you can also load different types of test software for automatically characterizing and finding faults in a full link, in a full system based on packets and receiving and analyzing packets. It's really quite amazing. But let's just look at some of its very basic functions. Actually, let's see if we click on system. Let me see what I can get here. There we go, there's a bunch of stuff here under system, and let's see, you can get into some kind of a menu to, it's a little bit slow to respond. Here you go, options manager, installed options, and here you will be able to see all the different options that are there. You see he has channel scanner, GSM analyzer, he has this CW and CDMA1 and reverse link signal generator, so he has an ARP built into it, a T1 analyzer, power meter, very cool. Let's go back here. What else can we do here? You can actually install more options, oh, there you go, service. Let's see, adjustment system status, that's what I was looking for. There you go, I can take a look at the revision information here, blah blah blah. Not that exciting. Let's see, memory, should be good, battery, there we go, that's what I was looking for. So there it is. So now it's looking for, you can see the battery voltage is really low, but it seems like it's probably climbing. It says 217 milliamp of current. I'm not sure what Is that the in current, out current? I'm not sure, but obviously it's completely dead. You can see percentage charge 0 is well below where it should be, probably damaged, but nonetheless I'm gonna let it charge and see if we can recover some of that charge back. Now let's go back onto mode. Let's go to Spectrum Analyzer and launch Spectrum Analyzer. Let's see what that looks like. Waiting, blah blah blah. There you go, Spectrum Analyzer, very nice. Start frequency started at 10 megahertz. Stop frequency, what is the range here? 2.7 gigahertz is the highest range. 2.7 gigahertz. There you go. Yeah, it's not bad. It's making spectrum measurements. There's a jump here. I wonder if that's because of the down converter just has a much higher noise figure in that region. I'm not sure. I hope that doesn't mean something's wrong with it. But this thing will automatically level depending on the level the signal coming into it. Again, remember this is designed for a very specific application, but nonetheless we should be able to put a signal into it. So let me hook it up to my Keysight EXG, see if we can see a signal. Alright, I've connected it directly all the way over there behind the unit itself to the EXG, and that comes from the top, connected to the top, right over here into the unit. So now the question is, if I enable it, will we see anything? Let me get this centered again. Now enable, and there it is. You can see that wow, the noise floor moved up quite a bit in order to make that measurement. Probably internally it has to do some adjustments in order to be able to show that, because this is not really intended to look at a very wide range of frequency at once. So let's change that. Let's put the where is it, channel span. No, there's, again, it's asking for some channels because it's looking for a particular channel standard. There you go. So you can select, you know, what kind of standard it is, North American, CDMA, GSM, blah blah blah. Not interesting. But I want to, let's say, start it at 1.3 gigahertz and stop it at 1.4 gigahertz. There you go, and we can see our signal. It is indeed there. I can turn it off, turn it on, and this signal is at minus 10 dBm. Let's change it to 0 dBm. And in fact, it is indeed doing that, because you can see it up here that is 15 dB per decade, and I can change the level and change the scale here to 10 dB per decade, and the reference is at minus 20, as at 20 dBm. Let's make the reference at 10 dBm. There you go. I think it looks quite nice. It seems to work, and definitely the spectrum analyzer application seems to be working. So now the question is the CW generator working or not? Now for CW, we're gonna have to change the mode here. We can actually go under, let's see, antenna and cable analyzer. Nope, not there. What are we looking for here? There you go, signal generator, right there. All right. Whoa, that's interesting. So channel modulation, no, I don't want it. There you go, modulation, just CW. It's an interesting interface. You can see it's made for the being out in the field. It's not. It's an interesting way of displaying this. So amplitude. Let's say I want a 0 dBm signal. Can I do that? Oh no, the highest it can do is minus 23 dBm. All right, let's maximize that. And what is the frequency here? Channel 500. I have no idea what that means. Channel standards. Oh god. No, I am. There you go. Frequency. Thank you. Give me the frequency. So there you go. 1.85 gigahertz is fine. Frame reference, not GPS. Whoa. External. Interesting. Internal reference. Yes, please use the internal reference. Select. There you go. Internal reference. Minus 23 dBm. I'm assuming that's the largest signal it can generate. I'm going to try increasing them one more time to 0. Nope, minus 23 dBm it is. Fine. And let's see. Let's go over here. Oh, sorry for this beautiful camera work I got going on here. RF on. There it is. There is a signal. It's alive. That is a weird camera angle. Hold on a second. I apologize for this. Let's see what we got here. Is it minus 23 dBm at the right frequency? Fine. Peak search. There you go. That's pretty good. Minus 23 dBm almost exactly, and you got 1.864, which is at that scale it's about correct. So yeah, so it looks like we've got a working CW generator as well, which is pretty great. So yeah, the CW, if the CW works, then everything else works, because based on those two specific measurement capabilities, then you can do everything else. So for example, I can go under mode, and I can go under cable and antenna analyzer, and I can measure a one return loss, there you go, on just one port, and that's going to show me a return loss as a function of frequency. It's like a one channel reflectometer. And there it is. You can see it's measuring return loss. Is obviously not calibrated, but you can see the return loss is very good because it's connected and terminated directly into my spectrum analyzer. So naturally, it's going to have a pretty good return loss. And it's only looking at a very, very narrow frequency range. So I can change the start frequency, let's say from 1 gigahertz, and I can stop it, at 2 gigahertz, for example. And now I should be able to do that from the beginning to the end, taking its sweet time. There it is. You can see that it's fairly good. Yeah, reasonably matched, I would say. And again, not calibrated, but if I were to disconnect the cable from the top, that is if I can. Jeez, I really tightened that. Let me disconnect it directly from the instrument. There, so as soon as I disconnect it, on the next cycle of the measurement, there you go, you can see that it's beginning to go back up. See? It's averaging, that's why it's going up slowly. So it looks good. If that works, then everything else should be working. Now, some of the other cool things that it can do, for example, if you're on the doing antenna measurements here, it has a function called distance to fault. So what it does is that because it knows the frequency that is being applied, it knows the impedance of the system, it can measure where a fault in a cable is, because it depends on the distance to the end of the cable, where the reflection coming back is going to have a particular characteristic. It knows where the notch in the frequency will be depending on the length of the cable. So you can calculate and tell you, oh, your cable is underground and it's 50 feet from where you're measuring, you have a fault in the cable, or the antenna is disconnected. It can tell you exactly how far you are from where the cable has failed, which is a very basic measurement. You can grab that data from any vector or even non-vector measurement. So pretty handy. So anyway, just wanted to make a quick video showing you this, the capability of this, and just a quick one, and seeing it repaired, quite nice. Like I said, if you see one of these things on eBay, and normally they go for pretty good prices because people don't want to use them, and they think that this is not a capable unit, but it is a very capable unit. If you're a beginner, you want to get into RF, and you want to pick up something like this for a couple $100, go for it. You can learn a lot using something like this. It's not going to be as responsive and as fast as a spectrum analyzer that you might be seeing from Rigol or from Keysight or so on, but that doesn't matter. Tons of stuff to learn from, and for a couple $100, you can't go wrong. Anyway, I hope you enjoyed it. Let me know in the comment section, and I'll try to answer any questions you may have. Until next time.